As we continue in Algebra 2, we're going to look into expanding on what we know about inequalities. And I just want to refresh and bring back some of those inequality ideas from 8th and ninth grade when we were talking in 8th grade math and we were talking in algebra in foundations that some of the standards that we're looking at is solving one variable linear inequalities, including compound and represent these solution sets graphically and algebraically. And then we want to create linear inequalities and use them to solve problems. And what we want to be able to remember are what do these symbols mean? And here we have, I've thrown up 4 symbols here, and we should hopefully know that this is my less than symbol. This is less than or equal to. This is greater than or equal to, and that's how you read those. And whatever system that you use to remember these is up to you. Now there's different ways. I could turn around and make this an arrow, and I could say, well, my arrow is pointing to that direction, which is pointing to all the numbers that are less than where I'm at. That's one way to do it. And then I could also look at this equal sign, right? That is an equal sign, so I know if that appears, it's also equal to. And when graphing on a number line, that would be graphed with an open circle, and this would be graphed with an open circle because they are less than or greater than. They're not equal to, whereas, sorry, I forgot to do my shading, didn't I? So the circle is not included, but when we're equal to, we will have less than, and then it will also include that point, and then we have greater than. It will include that point and then everything to the right because that is greater. And then one last thing that we want to remember is the golden rule. And what that was is if we're going to multiply or divide across the inequality sign, you are going to reverse the signs. So for example, if I have negative 2x is less than 4, well, I need to divide away the negative 2, my coefficient. But when I divide by a negative number, then we have to switch the sign from less than to a greater than. So then the answer is going to be x is greater than negative 2 and not less than negative 2 because we had to reverse the sign. And if you need more clarity on that, if I just take any number, if I take, if I go ahead and take 2 is less than 4, that is a correct statement. Now if I were to multiply both sides by negative 2, well, if I multiply that by negative 2, that becomes negative 4. And then if I multiply 4 times negative 2, that becomes negative 8. And now, as you see, this is no longer less than. Negative 4 is not less than negative 8. Negative 4 is actually greater than, so that's why my sign would reverse because of that multiplication or division process. So going on, hopefully this was a good refresher so you are ready for today's lesson. To a couple of examples. When we solve these, we're going to solve them just like equations. We're going to remove our grouping symbols. We're going to simplify each side. We'll isolate the variable and then solve and check, of course. This portion of the answers, or this portion of the step is often the skip step that nobody does. But so we look here, we have 5 parentheses, x minus 5 parentheses is less than 40. Well, here we want to remove our grouping symbols, and by doing that we need to multiply 5 times everything inside. That's what those parentheses mean. So we end up with 5x minus 25 is less than 40. Simplify each side. Well, there's nothing more to do here on this side to simplify or that side. So now I'm going to go ahead and isolate the variable. And I will isolate the variable by using my inverse operations. And there you go. So if I have 5x minus 25 is less than 40. I'm going to add 25 to both sides because this is now going to become 0. And I will have 5x is less than 40 plus 25 is 65. Continuing to isolate my variable, I want to divide away the coefficient, and that is divide both sides by 5. And then this becomes 1x, or 1x. X is less than 13 because 65 divided by 5 is 13. So there you have it. X is less than 13. If we're going to graph that, have a number line, something like this. Let's call this 14, 13, 12. There's 13, and then everything less than 13 would be shaded in, and it would be an open circle. And then talking about our notation, I want to cover this just a little bit because interval notation, you may or may not remember that, and we would read this interval notation that this is considered union. It means it's a combination, and this is from negative infinity to negative 3. The bracket means it's included, parentheses means it's not included. So from negative infinity to negative 3, union, so also the parentheses of 2 to positive infinity. So looking on a number line, I know that I'm going to need negative 3 here. Okay, so I've gone and have my number line. So I know that according to my symbols, the bracket means that it touches, the parentheses means that it doesn't. So on negative 3, I am going to have a closed circle because it's a bracket, and on 2, I'm going to have an open circle because it's parentheses. That's what those mean. And then from everything less than negative 3, right? And then everything greater than 2. So that would be what that solution would be graphed like. So just a reminder where we're at here. What we'll look at and do, and then set builder notation. Well, looking at this, we have x is less than 5 or x is greater than 11 can be written like this. So it's x is less than 5 or x, or the union of x is greater than 11, because it can be any of those. So again, the U means union, N means intersection. Intersection would be where we have an and. So this is graphed very similar to this. But if we were to graph the other one, this one, you're going to see, I need to have 7 and 1 on the graph. Okay, so I have x is greater than or equal to 1. So I have, it is going to be 1 included because it's equal to, and then it is going to be greater than. So it's everything in the positive direction. And then the next one is going to be x is less than 7, so not included, so it's an open circle. And then I'm going to shade everything less than 7. And since it's and, what I'm looking for is this magical area between here and here is going to be where I'm going to find my solution, because it's where both of those, it's where those two solutions overlap. So that is an and statement. We're talking about our compounds. So as we go back, and then if we were to solve and graph these, we would solve them independently, and then we would graph them. So I'm going to do that real quick. And here as I solve and graph, what I've done is I've taken the equation negative, or inequality, negative 4 is less than or equal to 3x minus 1. I've gone and added 1 to both sides, which gives me negative 3 is less than or equal to 3x. Divide both sides by 3 here so I can get x by itself. So I end up with negative 1 is less than or equal to x. And then I've gone ahead and flipped my operation so I have my x on the correct side. You always want your variable on the left here for inequalities, otherwise it's going to give you a wrong statement. Doing the same thing, and I can go ahead and graph that one, I guess. So x is greater than or equal to -1, so didn't want that to happen. Greater than or equal to means it's included, and it is everything greater than. Okay, and if we go ahead and look at our next equation, we have 2x plus 4 is less than or equal to 18. Go ahead and subtract 4 from both sides so I can isolate my variable. And then I'm going to have 2x is less than or equal to 14. Divide both sides by the coefficient because I want to get my x by itself. So we have, that becomes 1. And so I end up with x is less than or equal to 7. So I have 7, again, less than or equal to, so it's a closed circle, and less than. So there is my graph. And my solution falls somewhere between and including -1 and 7 because that's where my two inequalities overlap. And that's the big thing there. I mean, you solve these the same way that you would solve an equation, and just remember your golden rule. When multiplying or dividing by a negative number, you want to make sure that you flip or rotate your equation, or your, not equation, but your inequality. And that is it.